They found a galaxy that shouldn't exist. No dark matter. None. And that single discovery just broke the most fundamental model we have of how the universe was built. By the end of this, you'll understand exactly what was found, why every major physics model says it cannot exist, and what it means for the dark matter theory that astronomers have built the last 100 years of science on. In 2018, astronomers pointed the Hubble Space Telescope at an object catalogued as NGC 1052 DF2. A galaxy roughly 65 million light-years away in the constellation Cetus. On the surface, it looks unremarkable, a faint, diffuse smear of stars. But when scientists studied how the stars inside it were moving, something was deeply wrong. Here's the rule that holds across essentially every galaxy we've ever observed: stars on the outer edges of a galaxy orbit too fast. Way too fast for the visible matter, the stars, gas, and dust to hold them in place gravitationally. They should fly off into the void. But they don't. And the reason we've accepted for decades is that there must be something invisible surrounding every galaxy, a massive halo of unseen mass, pulling everything together. We call it dark matter. It's not a small detail. Dark matter is estimated to make up roughly 27% of the total mass-energy content of the entire universe. It outweighs all visible matter 5 to 1. Every galaxy formation model, every cosmological simulation, every theory about how the universe expanded after the Big Bang, is built on the assumption that dark matter is everywhere, always, woven into the structure of existence itself. And then, NGC 1052 DF2 showed up. And the stars inside it were moving exactly as slowly as they should be if there were no dark matter at all. The galaxy's dynamics matched its visible mass perfectly. No hidden scaffolding. No invisible halo. Just stars, hanging in space, obeying only what you can actually see. Let's be precise about why this is so destabilizing, because this isn't just a curiosity. This is a galaxy-sized contradiction sitting in the middle of modern astrophysics. The prevailing theory of cosmic structure, called lambda-cold dark matter, or lambda-CDM, tells us that galaxies don't form first. Dark matter halos form first. They collapse under gravity, and then ordinary matter falls into them, cools, and coalesces into the stars and gas we can actually see. Dark matter isn't something galaxies have. According to our models, dark matter is the cradle that galaxies are born inside. So a galaxy with no dark matter is a bit like finding a pearl with no oyster. The shell came first. The pearl shouldn't be floating there on its own. And it gets stranger. NGC 1052 DF2 isn't just missing dark matter, it's also missing most of its stars. It's what astronomers call an ultra-diffuse galaxy, roughly the same physical size as the Milky Way, but containing only about 1% of the Milky Way's stars. It is enormous, and almost entirely empty. A ghost galaxy. A cosmic shell. The research team, led by astronomer Peter Van Dokkum at Yale University, cross-checked the data. They studied the velocities of 10 globular clusters, dense balls of ancient stars orbiting the galaxy, and used them as tracers for the total mass. The math kept coming back the same. Little to no dark matter. The finding was published in Nature, and it sent shockwaves through the astronomy community. But here's what they didn't tell you in the headlines. Before we get to what this discovery actually means for the future of physics, you need to understand something even stranger. Because NGC 1052 DF2 wasn't alone. A year after the initial discovery, Van Dokkum's team published again. They had found a second galaxy with no dark matter, NGC 1052 DF4. Same neighborhood. Same impossible fingerprint. Then other groups began scanning the sky more carefully, and they started finding more ultra-diffuse galaxies exhibiting similar properties. What was once a single anomaly was becoming a pattern. And patterns change science. Now two competing explanations emerged, and both of them are extraordinary. The first, these galaxies lost their dark matter. Not because it was never there, but because something stripped it away. The prime suspect is the large elliptical galaxy NGC 1052, which dominates that region of space. The theory goes that gravitational tidal forces from NGC 1052, like cosmic tides, tore the dark matter halo away from DF2 and DF4 billions of years ago, leaving only the visible stars behind, drifting in a gravitational structure they could barely hold together. If true, this doesn't break dark matter theory. It actually confirms it and adds a new chapter about how brutal gravitational interactions can reshape galaxies over billions of years. But the second explanation is far more radical. Some physicists argue that these galaxies are actually proof not of dark matter being stripped, but of dark matter never being real in the first place. Modified gravity theories, which propose that our equations for gravity simply break down at galactic scales, predict that some galaxies could naturally look exactly like DF2. No exotic invisible matter required. Just different physics. Here is what the discovery of NGC 1052 DF2 actually breaks, and it's more precise than the headlines suggest. It doesn't disprove dark matter. But it destroys the idea that dark matter and galaxies are inseparable, that you cannot have one without the other. And that distinction matters enormously. Because if dark matter can be separated from a galaxy, then dark matter behaves more like a physical substance, something that can be moved, stripped, redistributed rather than a fundamental property of space. That shifts how we have to think about it, how we model it, and how we search for it. And it opens a door. If dark matter can be stripped from a galaxy, then somewhere out there should be the opposite, a region of space with a massive dark matter concentration and almost no visible stars at all. A dark galaxy. An invisible structure. Something we can only detect by the gravitational shadow it casts on everything around it. Astronomers are already looking. The universe has a way of doing this. Just when we think we've sketched its blueprints, it shows us a room we didn't know existed. NGC 1052 DF2 is not a failure of science. It is science doing exactly what it's supposed to do, finding the edges of what we know and staring over them. We built a model. The model met a ghost galaxy. And now the model has to grow. If this broke your brain a little, subscribe. We drop one of these every week, and next time, we're going inside the largest structure in the observable universe. A wall of galaxies so massive that it should not exist under any current model of cosmic expansion. It's called the Hercules Corona Borealis Great Wall, and it is waiting for you.